Mistakes and mess-ups hurt, and yet they offer an opportunity to learn and grow, as simply stated by Albert Einstein. The only mistake in life is the lesson not learned. And so let's learn and grow together from Timbers Creek, and learn what not to do when you see this, a simple problem that requires a simple solution, right? Douglas County came to us when they start to experience erosion on Timbers Creek, a project located in Douglas County, a fairly small watershed, a tributary to Cherry Creek. Historically, an ephemeral system, but development started in the 90s, and within just a few short years, development was nearly built out. But the development did right. It preserved a decent stream network and wide stream corridors, and check structures were introduced to stabilize Timbers Creek. Everyone tried to do right. But Timbers Creek is deceivingly quiet until it storms, and then it wakes up, as you can see here through homeowner videos. And this is the problem reach. Between 2002, 2004, and 2008, the check structures that were installed had been flanked. And you can see here, noticeably, that an active channel was developing. The county and homeowners were very concerned with the loss to property, infrastructure, the trails, and the mature vegetation. And so we moved into action. I directed a design that flattened the over 1% slope to a mere 0%, widened and enlarged the channel to contain the flood flows, and put in large sculpted concrete drop structures to make up nearly 11 feet of grade, as you can see there. But within just a few short years, the trail that we were trying to protect was threatened again. And this time, we were also concerned with our large structures being undermined. And so within a year, I directed a repair to the original repair project, adding more granite rock and more concrete. Obviously, the drops were not big enough. And yet within a few short years, we experienced similar problems. We are still monitoring this repair project, and at some point, I would imagine that maybe a repair to the repair of the original repair project might be necessary. In 2017, the county and the homeowners reached out to us again, this time concerned about a reach that was upstream of the project I just shared. This reach was experiencing degradation, channel migration that was threatening properties and homes, and trails because of severe bank erosion. There's another reach that they brought to our attention downstream of the reach that I discussed earlier. Although beautiful, there were also concerns with trees, with property, with infrastructure. But this time, not because of degradation, but because of severe deposition. We didn't jump directly to a fix this time. We spent the time to understand the system. Wanted to share with you a couple of lessons learned from this project. Number one, thank you. We now know that a stable urban stream system must be founded on the following 5 pillars of hydrology, hydraulics, geomorphology, vegetation, and people. Timbers Creek is steep, sandy, and flashy. As such, it is very important that we understand the trajectory, of these 5 pillars at a system scale to ensure our solution will not just mask the problem at a project scale. Number 2, thank you again. Avoid a siloed design approach, which I employed with the first project. I imagined a solution, hired a team to implement my solution through a very linear design process that focused on just hydraulics. Instead, engage a multidisciplinary team and create a project atmosphere for collaboration. By employing a system approach through a multidisciplinary team, we were able to understand the problems and opportunities and spend our limited dollars more effectively. Mark, can you walk us through this?
Thanks, Barb. The first pillar that Barb mentioned was the hydrology, and as Barb showed, the watershed is nearly built out, and so the hydrology is mature, and so the stream has had time to adjust to the changes in hydrology, and so that's a set pillar, and then the next couple pillars are the hydraulics and geomorphology, and Muller and Stillwater work together to start to understand the trend of hydraulics in the geomorphic process, which I'll talk more about. When looking at a macro level, Stillwater Sciences, who helped us with the geomorphic assessment, identified 3 geomorphic zones for the entire 2-mile reach of Timbers Creek, with the source at the top of the reach, transport through the middle, and then the response at the bottom. A stream evolution model was then developed for the types of streams that we saw present along Timbers Creek. The entire length of Timbers Creek was broken up into segments, and then each segment was matched with a stage of the stream evolution model, and then mapped spatially, as you can see with the different colors. And even though there is generally source, transport, and response when you're looking at a macro scale, when you actually look and zoom in into a micro level, there are source, transport, and response areas present within each of the larger reaches. So even within the upstream reach, which is generally a source reach, there are areas of transport and response. And this is primarily due to the impact of development with road crossings, trails, trail crossings, and then utility crossings. Within Timbers, there are different types of channels present, which are at different stages of the stream evolution model. Some showing bedrock and widening and degrading. And then there are some single thread stages that are degrading or aggrading, and some that are within equilibrium. And then finally, there are some multi-thread stages. Stillwater also evaluated the sediment transport along Timbers Creek. Since it's a sandy system, the sediment transport was important. And sediment transport is probably best represented by what many of you probably recognize as Lane's balance. And Timbers Creek varies greatly from top to bottom, but is rarely within equilibrium, so at the center, like it's shown in this picture. This is our reality, living in the red at Timbers Creek. We have a very flashy system that is mainly a sand bed system.
And I just want to add, Mark, that this is actually our reality, working really along the Front Range and the plains. We have a very flashy, hydrology, which is your access at the top. And we're in a lot of sand or gravel systems access, vertically. And so, Timbers Creek fall in this vein, but many of our projects also fall in this vein. And so we're kidding ourselves if we decide that we can just start problem solving like I did without really understanding the geomorphic landscape. We're at a disadvantage if we don't start there. Sorry, Mark, just wanted to add that little thought.
Oh, great point. The sediment transport modeling really highlighted the impacts of crossings on the sediment balance. In our case, the sediment transport is artificially created a response geomorphic zone with aggradational tendencies on the upstream side of crossings and then degradation tendencies on the downstream. And even like we talked about on the upstream, it's a source reach, but there's still these different zones within that reach, again, mainly due to the human development.
Yeah, I just wanted to add, Mark, so I know, before I didn't give much thought to where I put, say, pedestrian crossings or utility crossings, but understand that those man-made elements can really disrupt really the geomorphic landscape of how sediment moves through the system. So being more so this really helped me to better understand, how sometimes our actions really can interrupt kind of the sediment exchange along creek slide timbers.
Absolutely. And the next pillar, vegetation community. So we brought on DHM to the team to evaluate the ecology along Timbers Creek, which is another really crucial pillar to stable stream networks. So DHM evaluated the 2-mile stretch and picked out 7 different ecological zones along Timbers Creek, and the zones really vary greatly from downstream to upstream. But you can see with the different colors represented how much variation there is. They also broke the creek into 15 different segments and then identified potential improvements that could be implemented within each of those reaches. So when we got the team together, we sent out DHM to perform the ecological assessment and Stillwater to perform the geomorphic study, and they both identified almost identical segments of the channel, which is interesting, not totally surprising, but it really just shows how linked the ecology and geomorphology of the creek really are. And in most cases where the vegetation is really struggling and is not diverse, the channel is also struggling. DHM also inventoried all of the existing vegetation along the creek from top to bottom, and then they noted what vegetation was really successful in each of the different environments. And this is just really invaluable when developing planting plans and seed mixes. So we are not just using the standard seed mixes from the local municipalities, and not to say these standards are bad, but they can't be applied in every situation and should be evaluated on each job to really pay attention to what species should be installed with the project to give it really the best opportunity for success in its environment. And then the final pillar is the human connection. So in the past, we've piped stormwater, we've put it in concrete channels, just trying to move water as efficiently as possible. And now we're really trying to move towards understanding how stable streams and healthy vegetation can enhance the human experience. As people, we want to enjoy and spend time near our streams. And in this case, there's a trail running all along Timbers Creek from top to bottom. So it's really important to the community.
And just to make a point, Mark, that the reason this project became a project and was a priority for the county and the Metro District, I wish we could say that it was because of geomorphology or hydraulics, but it was because of the connection with people. There was a safety hazard that was now present. The trails were no longer, safely usable by the homeowners, and this area was no longer serving as an amenity to the community. And so because of the human connection piece, it's actually the pillar that prioritized this as a project. So it's a very important pillar that we often kind of prioritize last.
So as Barb discussed earlier, there are a lot of issues along Timbers Creek, and probably upwards of $10 million worth if we were to actually address all of it. But after the evaluation of our team that we performed, we identified a project area that could improve the channel and really be the best use of the available funds. And that was just downstream of Pinery Parkway.
We just kind of, this area is shown here, right, Mark?
Yep, exactly.
Great. Oops.
So the existing channel, there was multiple head cuts moving upstream, bank erosion, several sanitary sewer crossings that we mentioned previously that were at risk, trails, and so something needed to be done to step in and just address those issues. So like Barb mentioned, in the past, we tried the harder approaches such as concrete, sculpted concrete drop structures, riprap to fix Timbers Creek, and we've really had varied success with that. These approaches, they're all tried and true methods that we have in our engineering toolboxes, and they've worked successfully all over the Front Range, but not necessarily at Timbers Creek. So we had to think a little differently, and this time as a team we tried to balance all the pillars with a softer approach. The geomorphic assessment identified some of the areas that could be left alone, and over time the channel would evolve and widen to eventually achieve stability. So we tried to widen, flatten, and really reconnect the floodplain where possible, while still protecting trees, infrastructure, and trails. So essentially trying to speed up the evolution model to provide stability right now. And the ecological assessment showed the necessity for healthy vegetation. So we developed an approach where the vegetation would do most of the heavy lifting to provide stability and create a living and resilient creek that over time would allow the channel to move and adjust as it needed without completely unraveling and putting people and property at risk. We knew the channel slope still needed to be flattened with grade control structures, so we decided to implement a variety of approaches, and I'll just touch on one. We used low height log grade control structures, and these logs, they'll slowly degrade over time, but they'll hopefully maintain stability while the channel and vegetation adapt. And we also knew water was going to be crucial for the success of the softer approach, so we installed clay cutoff walls at each of the grade control structures to bring the water to the surface to provide passive irrigation for the vegetation we installed. Just understanding the water to those plants was needed to help them survive and create that stability. And since the vegetation was key to the success of the softer approach, it was important that the proper species were installed using what we had studied earlier at Timbers Creek to place the right vegetation in the right locations to provide stability and then really increase roughness along the channel and over banks. So this is what we envisioned at the start, a softer and really a messier approach that will hopefully allow the channel to move and adjust while providing stability. And this is that same shot now, before and after. And just looking downstream, another shot before and after. So Nyhoff Civil was a contractor, and they wrapped up construction earlier this year with plantings going in late spring, early summer, and we've been happy with the growth we're seeing out there and optimistic. And the clay cutoff walls have been successful at bringing water to the surface.
I learned the hard way, so remember, take time to understand the system before you start problem solving. And also engage a multidisciplinary team and create a collaborative work atmosphere. You'll find that the result will be tremendous, even in terms of the bottom line. These are not apples to apples comparison in terms of costs. One is a 2010 cost and the other is a 2019 cost. But my point here is I can confidently say that it's going to cost less than $700 per foot to replace this 2019 project. And I'm confident in saying that it's going to cost more than $1,000 to replace the 2010 project. Now give that some thought. Thank you for giving us a few minutes of your time today.